guys, welcome to Ride On Academia. Alright, today we're going to be looking at the set theory. Alright, a set, as you can see, is a collection of interrelated objects. Alright, when we have interrelated objects and we collect them together, we bring them together, what we have is a set. Many times these objects are arranged, they can be arranged in a bracket. Alright, we can have 1, 2, 3, 4 and 5. In this case, the objects are numbers, right? And then they are all elements, okay, of the set A. Are we together? So this is what we call what we see as a set. All right, what the set theorem is all about. We want to see how we can collect and arrange interrelated objects. All right, in this particular video we're going to be looking at the introduction to the set theory. Okay, we're going to be looking at introduction to the set theory. We're going to be showing us the element, like I said, of this set A. All right, the element of this set. Now we have 1, 2, 3, 4. Everything you can see in this bracket, all right, is an element of the set A. Now we can also have something like a subset. Okay, a subset is like a baby set, it's like a child set. All right, when we have a subset, it means the main set becomes the universal set. All right, now let's assume we have another set B. All right, and our set B is 3. The element of set B are 3, 4 and 5. All right, we have 3, 4 and 5 are the element of set B. Now if you look at the set A, right, every element of B is also an element of A, right? In this case we can say B is a subset of A. All right, B is a subset of A. Okay, and then our A in this case can be called a universal set, like the mother set. All right, so we can call our subset a baby set, and offspring is a derivative, okay, from the mother set. Okay, so we can call our A the universal set. Our universal set can be denoted by the symbol of a U. All right, we can use this for our universal set. Now in this particular video we want to be seeing the concept of the union of a set, intersection of a set. All right, so I'm going to be doing, let's see if we can get a set C. All right, we have 1, 2, 3 and then 4. Okay, now we're going to be looking at, let's compare these two sets together, set B and set C. Okay, now when we have the intersection of a set, all right, intersection, when we have an intersection of set, okay, we are trying to look at the similar items, the similar elements in both sets. So if we want to have the intersection of set B and set C, right, this is the symbol for intersection. If we want to have the intersection of set B and set C, that means we want to be looking at the common element in our set B and C. Okay, what can we find, what element can we find in B, and we can also find that element in what, in C. All right, as you can see, 3 is common in both places, 4 is also what, common. So when we say the intersection of B and C, we are going to be having 3 and what, 4. These are the elements. Okay, and then lastly, let's also look at the union of a set. Now when we have union is the other way around. Okay, the symbol is, let's say we have B union C. All right, and this is our B union C. We want to look at the union of the set B and C. That means we want to merge the entire set together. All right, whereas intersection is just looking at only the similar elements. The union looks at merging, okay, without repeating the rule that we're not going to repeat any element. Okay, we are going to merge everything together without repeating any element. So since we have 1, 2, all right, only 1 is going to be going there. Since we have this, so we're going to be merging that we're going to be having something like 1, 2, 3 is both found in both places, right? So we'll only be taking 1, 3, and then 4, and lastly we have what, 5. In that case, I'm going to be introducing you to a formula for calculating the union of a set. All right, when we want to calculate the union of a set, we can have 2 sets, we can also have 3 sets. All right, where we can have 3 sets, let me assume we have 3 sets, set D to be equal to 2, 4, 6, 7. This is the element of set D, right? Now we want to see the union. Let's assume we are seeing B union C. There is a formula for union of a set. All right, like I said, we don't want to repeat any element, right? So when we want to see the union of set B and set C, the format we use is this. We now look at the number of elements in set B plus the number of elements in set C, right, minus the number of elements in B intersection C. All right, I've shown you B intersection C, right? We have 2 elements. The number of elements in set B, we have what? 3. 1, 2, 3, right? 3 plus 1, 2, 3, 4, right? Then we have minus what? 2, which is our B intersection C, right? So you think the number of elements for B union C should be 4, 7 minus 2, which is 5. So that means we have to have 5 elements, as you can see, without repeating anyone, right? Where we bring in our intersection so that we can minus the similar items, all right? The similar items will be left with only one of each. If we less our 1, 3 and 4, we're left with another 3 and 4, right? So this is the format that can work. With this, you can know that we are supposed to have 5 elements in our union. Now, what if we have 3 sets? 1, 2, 3. I want to unite them, union of this set together. When we want to have B union C union D, right? When we want to have B union C union D, we want to unite these 3 sets. Now the format to know the number of elements, we have number of elements in set B plus the number of elements in set C plus the number of elements in set D, right? 1, 2, 3. Now we now subtract the number of elements in B intersection C, subtract the number of elements in B intersection D, which is subtract the number of elements in C intersection D, right? And then we're going to be adding. So we are subtracting for the intersection, right? And then we're going to be adding the last one, the elements, the number of elements in B. We'll be adding, right? B intersection C intersection D. So it means now when we look at this, let me explain quickly. When we look at this element on the board, this set on the board, right? We have 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. Okay, 4. Okay, now let's see what I'm trying to say. Number of elements in set B, we have 3, right? 3 elements. For set C, we have 4 elements. For set D, we are left with 4. And then when we want to subtract, we begin to look at our intersection B and C, right? What is common? We have 1, okay, and then 4 is common. That's 2. So we're going to be lessening 2. Now when we go to B intersection D, what is common in this place? We have just 4, right? Just 4 is common, so minus 1. Then we'll go to our C intersection D. What is common? We have 1, 2, right? So we are minusing 2. And then lastly, B intersection C intersection D. That is what is common for the 3 sets, all right? We're going to look at what is common in the 3 sets. Now, if you see, we can find that 4, okay? 4 is common in the 3 sets. So we only have 1 common thing. So we're going to be adding that 1. So by the time we have left all this and added, we're going to be having the number of elements when we are uniting the 3 sets together, okay? So we're going to be having what? 3 plus 4 plus 4, okay? Minus 2, minus 1, minus 2, okay? And then plus 1. So that's going to be giving us what? 7. And then we have 11, right? Minus 2, we are left with 9, 8, 6, and then 7. So if when we unite these 3 elements together, we're going to be having what? 7 elements. So let's try it. When we want to have our B union C union D, right? We're going to be having what? Like I said, we're not repeating any element, right? So we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, and we have what? 7. So by the time you count without repeating any element, right? 1, 2, 3, 4, 5, 6, and what? 7. So this formula serves as a guide to tell us the number of elements that it should be available in a union, all right? Where if the union is just 2, this formula works for us, and if the union is 3, want to unite 3 sets, right? This formula works for us. So this is the end of our introduction in this video. In our next video, we're going to be looking at the Venn diagram. Don't forget to like our videos, subscribe to our channel if you haven't, and share our video with as many as you can. We'll see you in our next class. Thank you.